Alright guys, today I'm going to show you how to solve trigonometric equation, but this time in radians. We have learned how to convert radians to degree and degree to radian. Now we need to be able to solve a trig equation in terms of radians. So like in terms of 2 pi or negative 2 pi, how do we solve some trig equations? So I'm just going to show you how to do 4 different kinds of questions. That should give you enough idea about how to solve it using radians. Alright, so the first question I'd like to show you how to do it is tangent bracket x minus pi on 6 is equal to square root of 3. And the question asks you to find x between 0 and 2 pi. Alright, now I hope you still remember from the previous lessons, the first thing you do is you need to pay attention to what's inside this bracket. The domain of x is between 0 and 2 pi. But however, here is x minus pi on 6. So the first step you do is you need to change that into x minus pi on 6. Here's minus pi on 6. And you're going to minus 2 pi by pi on 6. Alright, so you need to change the domain. Alright, this is really important. Change the domain, and that becomes 12 pi over 6 minus pi on 6, which is 11 pi on 6. Alright, so here is 11 pi on 6. Alright, now let's start to do this question here. Alright, so the first step here is finished. Now the second step is we are going to work out what is the answer for x minus pi on 6. So tangent inverse root 3. Alright, tangent inverse square root of 3. So minus 1. Alright, okay, so what's tangent inverse root 3? Alright, now if you remember from your special angle tables, that is equal to 60 degrees, all right? But this time we cannot write 60. Remember, we're dealing with radians, all right? So you can't just write 60 here. It doesn't make sense with the radian measure here and the degree measure in the same equation. It's not going to work. So how do we convert 60 to the radian? Well, 60 is equivalent to 180 divided by 3. So therefore, that becomes pi on 6, or pi on 3, sorry, pi on 3. So 60 degrees is equivalent to pi on 3 in radian. Now remember, because pi is equivalent to 180, so 180 divided by 3 is equal to 60. So that's pi on 3. That's the first answer. Now remember, once you finish this, please do not move this one over and try to calculate what's x. You need to work out all the answers between negative pi on 6 to 11 pi on 6. We still haven't finished this question yet, all right? So now we need to continue to find the second angle. This is tangent. Remember I told you guys all station to central tangent. The second angle is 180 degrees plus the angle we get for the previous one. But this time, because we're dealing with radian, so therefore we're using, instead of 180, we're using pi. Okay, so it's going to be pi plus theta. For sine is pi minus theta, and for tangent, for cosine is 2 pi minus theta. All right, so the second angle would be pi plus pi on 3. Okay, what's pi plus pi on 3? It's 4 pi on 3. So I'm just going to write 4 pi on 3. All right, now 4 pi on 3, we need to compare. So this is the tricky part. Is 4 pi on 3 still within the domain? All right, now we do need to check. Try to time this by 2, and you are going to get 8 pi on 3. That's 11 pi on, so 8 pi on 6. That's 11 pi on 6. So still within the domain. Now we need to move on to find the next one. All right, what's the next one? Next one, we need to plus this angle by 360 degrees. All right, so that becomes 2 pi. It's 360 is plus 2 pi. All right, so what does that become? All right, so if we make the same denominator, that's 3. Here's 6, and when you plus them together is 7 pi on 3. All right, now check. 7 pi on 3, if I times by 2 here, that gives you 14 pi on 6. Now 14 pi on 6 is greater than 11 pi on 6. So this is not the answer we need, all right? We need to remove the answer here. All right, that's not something I need here. All right. So that's it. How about the negative side? All right, can we check if the negative side will have any angles or not? So now we need to go back to my first answer here, which is pi on 3. So we need to minus pi on 3 by 2 pi, because remember 2 pi is a whole revolution. All right, minus 360 degrees minus 2 pi, that gives us pi on 3 minus 6 pi on 3, which is minus 5 pi on 3, and this is definitely less than negative pi on 6. All right, so therefore we don't have to worry about it. That means there's only, we have only 2 answers here. The first answer, pi on 3, the second one is 4 pi on 3. Have we finished the question? All right, no, because the question says, you need to find x. That's x minus pi. So your final step here is plus all the answer here by pi on 6. 4 pi on 3 and you plus pi on 6. That's what you need to do. All right, so for the first one, all right, if you plus 3, 1 over 3 by 1 over 6, make the same denominator, that will be 6 here and that will be 2 pi. So it will be 3 pi on 6. And that's equal to pi on 2. That's the first answer here. And then the second answer is this one. All right, we need to still do the same thing. Make the same denominator. So that's 6. That's 8 pi plus pi, which is 9 pi on 6. On 6. Now, hopefully you remember to simplify this one here. So that gives you 3 pi on 2. That gives you the final answer. So you've got 2 answers here, pi on 2 and 3 pi on 2. All right, that's how you solve for this first question. All right, so you need to make sure that if this is x minus pi on 6, you need to change the domain before we work out the answers. And then now everything is in terms of radian. So make sure that you do need to know how to convert from special angle like 60 degrees, 30 degrees into radians, and you get to the answer. Now, if the question asks you to leave in the exact solution, that's what you need to leave. Most of the time, the question will ask you to leave in the exact solution. If the question asks you to work out in 2 decimal places, and that's the time you use your calculator to work out the answer. But this time, you need to make sure that you change your calculator setting from degree measure to the radian measure. Because if you don't change it, all your answer will be incorrect. All right, so this is very important. And the way to change it is if you press shift and press mode. All right, you should be able to see, I'm pretty sure, let me check. If you shift mode, and number 3 is for the degree, and number 4 is the radian. You just need to select radian when doing questions with radian question, all right? All right, so that's the first example I'd like to show everyone. All right, I'm gonna move on to the second example. Okay, so the second question I'd like to do is this one here. Question B, 6 tangent square x is equal to 5 sect x. How do we solve this question? All right, now again, I want to solve for the answer between pi, 2 pi, and 0. How do we solve this one? I hope from the previous lessons you still remember that whenever we see 2 trig ratio equations in one equation, the idea behind it is we need to change that into 1 trig ratios. You can either change into sine or cos or tan or sect, but you need 1, not 2. So how do I do this? There is a formula, Pythagorean identity, that tangent is equal to, all right, so let's just write this one here. 1 plus tangent square x is equal to sect square x. So therefore, tangent square x is equal to sect square x minus 1. All right, so therefore we can change that into sect square x minus 1 is equal to 5 sect x. That is the first step. All right, so that becomes a quadratic. All right, so let's rearrange them. Minus 6 minus 5 sect x equals to 0. So you just expand and move the terms on the right to the left. All right, now keep rearrange them so you get a perfect, all right, a perfect example of a quadratic function here. All right, so that looks like a quadratic. So we've got 6 sect square x minus 5 sect x minus 6 equal to 0. So the way you do it is you're going to replace that sect x by another variable. Let's just call that a. So you get 6a minus 5a, sorry, 6a squared minus 5a minus 6 equals to 0. All right. Now from here, you're solving a quadratic equation. All right. I'm going to use the cross method to work out the answer here. So 3 and 2. That's minus. Okay, so here we go. That becomes 2a minus 3, and 3a plus 2 is equal to 0. In the future lessons, I'll teach everyone how to use the cross method to factorize quadratic equations or quadratic expression. It's much faster than the other methods. All right, so now you have a equals to 2 over 3. 3 over 2. And then you've got a equals to minus 2 over 3. Okay, all right. So now we have these two answers. Have we finished the question? Well, no, this is only for a. I need to work out for sect x. So that means I need to calculate what's x. All right, so how do we work out x? Well, we know sect x is equal to a. So we have sect x equals to 3 over 2. And we have sect x equals to minus 2 over 3. Now, it's really hard to deal with like a sect, right? So how about we change that sect to cosine? Because we know that 1 over cosine is sect. So we can do the reciprocal. So cosine x is equal to 2 over 3. And the cosine x is equal to minus 3 over 2. All right, now, very interesting. If you have this experience that you will find is really easy to deal with, all right? There will be no answer for this part of the equation. Just because this answer here is negative 1.5, it's less than negative 1. You can use a calculator to try, but there is no answer here because cosine function oscillates between 1 and negative 1 for a simple cosine x question. So therefore, it's not possible. All right, and then if you do use a calculator, you will see your calculator display math error or syntax error. All right, okay, so that means we only have one set of answers we need, set of equation we need to work out, right? Now remember, this time we're dealing with question in terms of radian. However, this 2 over 3 is not a special number. So therefore, you are going to get like decimal numbers here. So how about we do that to 2 decimal places? And please, really important that you do need to change your calculator setting to radian, okay? So you have a little R on top of it, the screen that says radian. All right, so x is equal to cos inverse 2 over 3 is equal to. All right, let's try this. All right, in 2 decimal places, in radian, it will be 0.84. That's not degree, but that's radian. All right, how do we find the second answer? This is still the same, all station to central. It's a cosine question, so we're going to use 2 pi minus that 0.84 to get the second answer. All right, so I'm going to use 2 times by pi minus the answer in 2 decimal places, and it will be 5.44. That will be the 2 answers that satisfy this domain here. Okay, all right. That's how you solve it, all right, for this question here. It does take a long time to solve this question. The reason for that is because when you first look at a question, you need to be able to change that tangent square x into 1 plus sect square, secant square x minus 1. All right, and then you also need to realize that becomes a quadratic style of question. And then you're going to replace that sect x by a. So you get a quadratic equation, and you need to solve a quadratic equation. And then after you finish all of them, you still have to work out which one is the correct answer here. There will be no answer for the second part of the equation, and you're going to work out the final answer. So it's not that easy. All right, we're going to move on to the next one. All right, so the next question looks like it's pretty easy. All right, question D. It's a simple one here. Question D. Use a different color. All right, so 3 sine square theta plus 8 sine theta minus 3 is equal to 0. And the question asks you to change, leave your answer from 0 to 2 pi in radian. possibly to 2 decimal places, okay, to 2 dp. All right, now, very similar to the previous one. This is quadratic. All right, so first step, let sine theta equals to a. So just replace sine theta by a. So you get 3a squared plus 8a minus 3 equals to 0. All right, use cross methods. You can factorize it here. That becomes a plus 3 and 3a minus 1 equals to 0. So therefore a is equal to minus 3 and a is equal to 1/3. All right. Once you finish that, please replace this sine theta back. So therefore sine theta is equal to minus 3. Sine theta is equal to 1/3. Now, again, you can try use your calculator. There will be no solution for this one. The reason for that is because sine function is also oscillating between 1 and minus 1. So it's not possible to get an answer -3. All right, in the future lesson, I will teach you about curve sketching for trigonometric function, and then you will know just why. So therefore, that means we only have one set of answers to find out. All right, sine theta is equal to 1/3. All right, okay, so start with here. Sine theta equals to 1/3. Theta is equal to sine inverse 1/3. Remember, it's in radian, so double check with your calculator setting. So shift to sine 1/3 in radian is equal to 0.34. That's the first answer. All right, what's the second answer? This is all station 2 central question. This is sine question. Sine, the second answer is using pi minus the first answer there. So you will have 2 sets of answers. All right, so the next one's pi minus the answer, which is 2.80. And that is the answer in 2 decimal places. And that's it. That's the answer for this question here. All right. Yeah. So again, make sure that you realize this is a quadratic, and make sure that you know how to factorize it. Use cross method or use whatever the method you use, and then do test which one is the answer here. Sometimes you do get 2 answers, 2 sets of equations. They can all produce answers, but however, for this case, again, sine theta equal to -3 does not produce any answer, okay? And then you're using your calculator to work out the answer in terms of radian. Now remember, all right, in the previous lesson, I told you guys that not every radian are in terms of pi, only some special ones that are in terms of pi. So you can have something that's not in terms of pi. All right. I'd like to do one more, last one. Okay, so hopefully that 4 example give you enough idea about how to solve questions in radian. All right, let's move on to the last one. All right, so the last example, I'd like to do something that's slightly easier, but this time I'm going to increase the domain to, increase the domain, all right? So you'll have more answers. All right, so A, B, C, D, and E. Oh, A, B, C, D, E. Yep, okay, all right. So this is the question, all right? Sine theta is equal to, just going to give you a very easy one, all right? √2/2. Something that's really, really simple. And then you are going to find the answer between -2 pi to 4 pi. Now here comes the domain. This is the tricky part. You need to write your answer in the exact form. All right, so what do we do? Starting with the first step, special number here, √2/2. So hopefully you realize the first theta is 45 degrees, but we don't write 45. We write in radian, pi/4. All right, now pi/4 is within the domain. However, we need to do a lot before we can get to the final answer. All right, so now we need to move on to the second answer here. Second answer, that's for sine. It is always pi minus or 180 minus if it's in terms of degree. So pi minus pi/4, and that's 3 pi/4. All right, so these are the 2 most important answers here. The first answer and the second answer. Once we have these two answers, we can generate more answers based on these two. So I'm just going to do the positive side first before we move on to the negative side, okay? Positive side first. So the third angle, I'm just going to keep adding 360 degrees, but this time again, radians, so keep adding 2 pi. So 2 pi plus pi on 4. If you do the calculation, that is 8 pi on 4 plus pi on 4, and that's 9 pi on 4. So the third answer will be 9 pi on 4. All right, that's the third answer. And keep going. All right, keep going. Next one is here, this one. All right, how do we know when we need to stop? Well, that's 4 pi. And 4 pi is 16 pi on 4. We need to go all the way to 16 pi on 4. And that's 9 pi on 4. So keep going. So the next one is 3 pi on 4, and I need to plus 2 pi. Do the same thing, all right? And then that's 11 pi on 4. That's the fourth answer. 11 pi on 4. Now you can do one more time. You can plus the third answer by 360 degrees, or 2 pi this time. And you will notice that if you plus that 8 pi with 9 pi, that becomes 17 pi on 4, which is greater than 16 pi on 4. So we stop at this point. These are all the positive answers. Now we need to focus on the negative answers. We have negative answers. That's within negative 2 pi. So what do we do with negative answers? Well, we still take the first and the second angle. It's always using the first and second angle to generate more angles, right? So this time I'm going to use first angle, but subtract by 2 pi. So pi on 4 minus 2 pi. Pi on 4 minus 8 pi on 4, and that gives you minus 7 pi on 4. Okay, so the next answer will be minus 7 pi on 4. And that's the fifth answer. Keep going, all right? Because this answer here is minus 8 pi on 4. So we need to keep going. Now we need to take the second answer, minus 2 pi, minus 360 degrees. So 3 pi on 4 minus 2 pi. All right, and that becomes negative 5 pi on 4. As you can see, that steps is really long, all right? Negative 5 pi on 4. Now that's the sixth answer. All right, really long. It does depend on what is the domain they give it to you. So right now, how many answers I have? I've got 1, 2, 3, 4, 5, 6. 6 answers for that question. Now remember, I told you before, without the domain, the trigonometry equation, you can have unlimited number of answers. And that's the reason why the question needs to tell you what is the restriction by telling you the domain, so you can restrict the domain and you find only a certain answers within the domain. And for that question, we have 6 answers. So please remember, first step is simplifying the questions, and second step is to find the first angle. Once you get the first angle, you can get the second angle by using all station to central. And once you get the first 2 angles, then what you need to do is you are going to use plus 360 degrees, plus 2 pi, or minus 360 degrees, or minus 2 pi to generate more angles towards the end. All right, so the most important thing is about finding the first 2 angles, all right? Okay, so that's all I want to teach you for the trig equation in radians. Hopefully this lesson really helps you to understand how to do the questions. And I will see you next time. Thank you.